Okay, so this is the last part of day one lesson, and it is in regards to cyclic aliphatics. So carbon's atom can form rings, and those bonds are unusually weak. So it is more reactive than normal aliphatics. Naming of cyclic aliphatics will be the same as the previous ones, as the aliphatics that we have said. But the only thing that we will add into it is the word cyclo. So if we have butane, let's say, then we will have structure like this, okay, which is but now if we take those two ends, and kind of put them together, then what we will see is a cycle. So carbon will be like this, and the cycle will be here, and then we will have hydrogens to complete the four bonds that carbon is forming. And then this will be named as a cyclobutane. If we are drawing the structural diagram, then we'll have added here hydrogen, 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 hydrogen. In all of those lines here at the end, we will have hydrogen. So in other words, the line diagram of cyclobutane will be something like this. The general formula for a cyclic aliphatics will be CnH2n. So if we have, in this case, if we have 4 carbons, so one will be C4H8, and this is cyclobutane. You can see it here. Even in our example that we had here, we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogen. So we always will add the word cyclo, and then let's suppose that we have C3H6. That means that we will have 3 carbons that are in a cycle together. So it will be carbon, 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 and then we will have hydrogen, 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 hydrogen here. This will be called as cyclopropane, because prop is the 3 and then pane. But if we have something like 1 ethyl to propyl cyclobutane, then what we will see is we'll have a butane as the main chain, the cyclobutane as the main chain, and then we can label or number carbons, counterclockwise or clockwise, doesn't really matter. So 1, 2, 3, 4. And then here we will have on the first position, we will have the first branch, which is an ethyl. So C2H5. And on the second position, in the second position of carbon, we will have propyl. So we'll have C3 H7, and then on the 3 and 4 we'll have just 2 hydrogen, 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 and hydrogen. Okay, so this will be how we name an cyclic aliphatic. But let's see now if we have a double bond or a triple bond. Double bond. First, let's suppose that we have this to draw the structural diagram. Cyclobutene. So this is the indication that we have a double bond, and honestly, it doesn't, since it is not mentioned as to where, then it doesn't really matter. So we'll have 4 carbons, carbon, 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 and here we will have a double bond, and one, if we label it 1, 2, 3, and 4, then we will have 1, 2, 3, 1 hydrogen here, or 1 hydrogen here, and 2 hydrogen on 3 and 4. Or if we take that we just mentioned, the previous example, and then we have 1 ethyl, 2 propyl, cyclobutane, then in position 1 and 2, so carbon, 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 carbon. If we label it as 1, 2, 3, 4, doesn't matter clockwise or counterclockwise, we will have on position 1 we'll have 1 ethyl. So I will draw it with a different color. So we'll have C2H5 in the second position, the second location, we'll have a propyl, so C3H7, and then here we will have a double bond, so it will be something like this. Okay, this is in terms of the cyclic aliphatics, and then the next lessons will be the aromatics and derivatives of hydrocarbon.